So we're still looking at Chapter 6. Sorry guys, all the settings on this instructor's workstation were reset. So the first thing I want to talk about is the difference between a class member and an instance member, or a class variable and an instance variable. If you look at cat. So if you have an object, or like you have a blueprint, and it's for building a house. And sorry guys, for you watching at home, you're just going to have to listen for a minute because I'm drawing on the board. You have a blueprint. From that blueprint, you could hire teams who would build, an infinity number of houses, right? You could build as many of them as you wanted to, as long as you had the money to pay the contractors to do it. So this is the class. The blueprint is the class, and the houses are the objects made from it. And so each house could have its own traits, its own instance variables. Like, what is the color of the house? What is the address? Maybe they all have the same color. Maybe they don't. Maybe they come in all different colors. Probably they all each have a different address. So the instance members differ on an object-by-object basis, or at least they can. If they happen to have the same value, it's just a coincidence. But then you can have things that apply to the class as a whole. The designer of the blueprint, Frank Lloyd Wright, made the blueprint. So Frank Lloyd Wright is the guy who designed all the objects. The designer does not apply to each object. It doesn't change on an object-by-object basis. If these houses were made from this blueprint, then they were all designed by Frank Lloyd Wright. So that's a class member. I will go and write this down now. And class members, whether they be variables or methods, are declared with the static keyword. So we have a blueprint for a house. The blueprint is the class. The houses you build based on that blueprint are objects. There will be attributes, variables, that apply to each individual house. These are instance variables. Then there may be attributes which apply to all of the houses. They actually apply to the class itself. For example, the designer who made the blueprint. So you have a blue house, red house, yellow house. Color would be an instance variable. All of them are designed by Frank Lloyd Wright. So architect would be a class variable. And somebody could argue, yeah, well, why don't you make architect an instance variable and just set it to the same? Yeah, you could do that. So class variables you don't use nearly as often as you do instance variables because you're always trying to come up with, ways of describing things, and when you come up with those ways of describing things, you list their attributes, right? A patient's height and I almost said a patient's height and width, that'd be odd. A patient's height and weight, their blood type, all of that differs on a patient-by-patient basis. So those are all instance variables, and it doesn't readily come to mind. Okay, I see the idea of a class variable that I could apply to every patient, But we are going to come up with a class that has a class member, a class variable. So instance variables are defined with the static, instance variables, let's rewrite that. Class variables and methods are defined using the static keyword. Instance variables and methods do not use the static keyword. Okay, so Dad is talking about instance versus class. And when I say members, I mean either variables or methods. Another idea that we have with classes is the idea of providing constructors. A constructor is a method that has the same name as the class itself. No return type because it's actually returning the object itself, and is called when the object is created by the new keyword. So what would you do with a constructor? Well, say you have a car class and it has 3 attributes under it. It's got a color of the car, it's got a year of the car, and it's got the manufacturer of the car. Well, with a constructor, you might be able to create it like this. Car C1 is equal to new car, and then set those 3 variables. It's a red 1981 to Volvo, or whatever, right? Then if you want to make another one, you can put in different values. It's a white 1990 Ford. That kind of thing. The constructor is what lets you pass in those values like that. Other words, if you didn't have that, you might have to do something like this. Car 3 is equal to new car. C3.setColor to red. C3.setYear to 1987. C3.setManufacturer to Nissan. Right? If it's more convenient for you, the programmer, to be able to specify those values as you create the object, make a constructor that allows you to do that. If it's not convenient, don't bother, you know. If this is how you want to do it, that's totally fine. You don't have to create a constructor for every class, but it should be along in the checklist of things that you're thinking about when you do create a class. So, class creation guidelines, I always vary these just a little bit, but so data private, methods public, or variables private, methods public, getters and setters, also known as accessors and mutators. And then add a constructor if it makes the class easier to use. Add a toString method if it makes the class easier to use. What toString would do is it would turn the data that's inside the class into something that could be printed on the screen for debug purposes or whatever. And then add a .equals method to compare objects if it makes the class easier to use. Again, all of these are if it makes the class easier to use. Do you have to do this stuff? No. But let's think about, say we have a cube class, class cube, and it's got 3 variable types, and I'm going to ignore the private data for now. It's got a public, int, x, y, and z, right? 3 coordinates. Or let's just make it a point. It's a point in space that has an x, y, and a z coordinate. So you start making some points. Heck, maybe you even add a constructor for it. Public point int x. We ought to actually do this. Int y, int z. We ought to do this in NetBeans. And it sets the values. Going to kind of skip over that little bit of magic there. So then what if you were going to use those points? Create a drawing program or something. Point P1 is equal to new point, and this one's at 0, 0, 0. To the dead middle of space. Then you make another one, point P2 is equal to new point, and this one's at 10, -5, whatever, 3. And then you make a third point, equals new point, and it's also at 10, -5, 3. How would you tell to see if those points were equal, if they were occupying the same point in space? You would have to do something like this. If P1.x is equal to P2.x, and P1.y is equal to P2.y, and P1.z is equal to P2.z, or whatever. In this case, I guess we'd be comparing P2 and P3, but you get the idea. Only if all those things are true, yep, they are equal. Else, nope, they are not equal. I wouldn't want to have to write that logic every single time I compare 2 points. I would rather be able to do this. If P1 dot equals P2. Like that, right? Just like the string class. Objects should never be compared with equal equal. Why? Because equal equal would just compare their addresses to see whether they were allocated in the same place. So yeah, if you do this, or point P1 is equal to new point, and then you did point P2 is equal to P1, you don't have 2 points, you just have 2 references to the same object. And then if you did if P1 equal P2, it would say yes, that's true. But that's the only time in which doing equal equal would actually work. Even if you created, 2 objects, 2 different points with 0, 0, 0 and 0, 0, 0, if you used equal equal, it would not say that they were the same because they are not residing in the same exact memory byte. So instead you want to write a dot equals method that lets you check to see whether those objects are equivalent by whatever criteria you decide are the same or not. Like maybe 2 patient records. They're the same if they both have the same patient ID. That kind of thing. So let's go ahead and flesh out this point class. Let's do NetBeans. I think I already have it open. Did start my recording, did I not? Yes. Okay. Except points are kind of boring, so I'm going to make it a cube just so that we can calculate a volume, right? Or maybe we'll make it a sphere. Yeah, we'll make it a sphere because it only has 1 data element. All right, I'm going to just call this one February 1. But we're going to demonstrate a sphere class. We want to be able to make 2 spheres. We want to print some information out about the spheres. Background scanning, yeah, okay. Thanks. And again, all my settings are lost. Alright, so the way I want it to work is to be able to do this. Sphere S1 is equal to new sphere with a radius of 10. Sphere S2 is equal to new sphere with a radius of 10. Then I might want to print some information out about those spheres. Spheres. System.out.println S1 equals plus S1, like that. Now none of this is going to work yet because we don't have a sphere class, but we're just kind of outlining the way we would want it to work if we could, which we can. Once it's created, this kind of stuff should be possible. We may have to tweak it a little bit, but we're going to try to make it so that it follows this general paradigm. And if S1 is equal to S2, system.out.println, the spheres are equal. Now I'm going to copy that print statement because I'm going to make an else that says the spheres are not equal. Else, the spheres are not equal. All right, that's how I'd like to be able to use my sphere class. And then later on, maybe we'll add a get volume or get surface area, that kind of thing. But this will demonstrate several things. We'll be able to make a constructor, because without a constructor, we wouldn't be able to pass in any arguments when we call the new keyword. We will do a toString method so that when we print them out, it will print out useful information rather than just, yeah, well, let's take this one step at a time. Let's go ahead and make our sphere class. Now what we ought to do is go to our folder over here, our package folder. We see the package statement up here, and that matches that one. We could right click on this and do new Java class and make one called sphere. I'm just going to kind of take advantage of NetBeans, and if I click on the error right here, cannot find symbol, it's going to say create a class. I'm just going to go ahead and do that, just maybe just this once. It's even offering to create a class with a constructor, but I'm not going to do that. I'm going to roll the constructor button myself. But this is just the same thing as right-clicking on Feb1, doing new Java class, and calling it sphere. So I right-click on the error and choose create class. Yeah, now I have my class. What does every sphere need? It needs a radius. So double radius. We ought to make it private if we're going to follow my rules. So private double radius, in which case we would have to add some getters and setters. No, ain't no big deal. Let's do that. Public get radius, which return this dot radius, semicolon, into curly brace. Except I forgot to say what type it returns, so public space double space get radius, and then set radius, which doesn't need to return anything. So public void set radius 2, and inside the parentheses int radius, and we're going to say this dot radius equals radius. All right, now let's make a constructor. Otherwise, the programmer has to call set radius after they create the sphere. And I want them to be able to do that in one step rather than two. So in our sphere class, I'm just cleaning up some comments there. We're going to create a constructor. So public sphere, which takes as an argument the parameter radius. And what does it do? It sets this dot radius equal to radius. Something that might look nice would be if we called set radius inside this function. Don't do this. I'm going to demonstrate something. If we just called set radius here, and we passed in radius, it's going to give us a warning, and it'll work fine. But here's the warning. It's not telling us what the warning is. Overridable method call in constructor. And then it gives us some choices. Are we going to make the method set radius final? Are we going to make set radius static? Are we going to make it private? No, we're going to do none of the above. So what you can place in constructors, you really shouldn't be putting method calls in the constructor, or if you are, you need to be very, very careful about it. So I'm just going to leave it the way it was. The constructor sets this dot radius equal to radius. Now most of our code is going to compile. Maybe all of it will. Let's go look. Looks like it. Can't quite get it all on one page right, but we get the idea. I'm going to pad out the spacing of this to a more conventional spacing. All right. So I'm going to try building it. So hammer and broom. Said finish building, so I expect that it worked. I don't see the output. I'm going to run it, and there we go. Nope, 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 go away. And here's what happened. It ran, and then it printed out our spheres, and it said S1 is equal to that, feb1.sphere.@. S2 is equal to similar gibberish, and then it says the spheres are not equal. The way we were thinking about it, we wanted the spheres to say they were equal because they were the same radius. And we really don't want it just to print out the name of the class followed by this, hash code here. Instead, we want it to print out what the object is. It's a sphere of radius 10 or whatever. So in order to get these print statements to work, we need to add toString. And in order to get this comparison to work, we need to use dot equals. So I'm going to go back to the sphere class and make those changes. Public string toString. Now this is actually overloading. Shouldn't say overloading. It's overriding an existing method. And what do I mean by that? I'm going to cut this out. Don't cut it out. But if I type it over here, in my code over here, S1 dot, and it lists all the members, all the methods. Well, equals is one of the methods. Get class, and another one. ToString is one. There's already a toStrings method, but all the toStrings method does currently is print the name of the class followed by a hash value. So we want to replace it. Where did that toString method come from? If it's here, or if it's not here, then why can we get to it over in our client code? And the reason we can is because it's inherited. Those methods that we didn't write, the only things we put in there are set radius, get radius, and a constructor. But when we typed a dot, we saw a list of a whole bunch of methods. Those are all methods that are inherited from a parent class, a superclass. Every class in Java inherits from the object class. And the object class has those methods. It has a toString method and has an equals method. The methods that it has aren't that useful to us. ToString, we'd like for it to do something else other than just print the name of the object. And equals, we'd like for it to do more than just see if they're sharing the same allocated space. So we are going to override those, which means replace them with our own. And once we start talking about inheritance, we will start using the term overriding a lot. So anyways, let me get rid of that. Let me go back over here to my toString that I rudely interrupted myself from completing. I guess I didn't type it. Okay, so I'll just put it here. Public string toString. Notice that it's giving me a little warning. It's not a bad warning, it's just a suggestion. NetBeans thinks that we ought to add the @override annotation. And I'm okay with that. I'm going to go ahead and add the @override annotation. I'll talk more about what that means, but it's an indicator to the compiler that this method here is a method that overrides one in the parent class, in the class that we inherit from. So doesn't have to be there. It helps the compiler do a check. We'll talk more about what that check is later. I like doing that for one thing, just to get rid of that yellow symbol next to the method declaration. Okay, so let's declare a string. And let's fill that string with some good data. s.format. And we're going to use some placeholders. So sphere with a radius of %f. That'll do. End quote, comma, radius, or this dot radius. And then let's return s. Variable s may not have been initialized. I suppose that's true. I guess let's make an empty string. String s is equal to empty string. Okay, my mistake in how I formatted this entirely. I'm going to get rid of that. What I needed to do, and I apologize for this, when I switch from language to language, my brain does backflips. S is equal to string dot format. That's what it really needed to say right there. S is equal to string dot format, not s dot format. So let's run it. It built, or I built it first, hammer and broom, then green arrow. What output do I see? It says that S1 is a sphere with a radius of 10, S2 is a sphere of a radius with 10. It's still saying that the spheres are not equal, so I'm going to add a method that handles that as well. Dot. The problem is that I'm using equal equal, and all that does is do a comparison of the addresses. So I'm going to go over to my client code and make it say if s1 dot equals parentheses s2. This is the same way you compare strings. Hopefully in Java 1 you learned not to compare strings with equal equal, but by using dot equals. But that didn't really fix the problem. The output's going to be exactly the same because we have not provided an override for the dot equals method. So when I run it, it says they're not equal. Well, let's go add a method, dot equals. So above or below our toString method, public, Boolean, because equals is going to return true or false, right? So it needs to be Boolean. Equals, and what does it take? It takes another sphere. But really, you don't want to just make it a sphere that it accepts. See, here's my urge. I'd like for it to do that so that I can say, you know, and then I could, when we call it, we're passing in a sphere, everything works nicely. But that's not really good enough because the method that we are overriding does not accept a sphere. It accepts an object as the parameter. So we're going to have to do it like that, and then we're going to have to turn this object reference into a sphere. So sphere other is equal to, and we have to use a cast. We have to cast this object into the form of a sphere reference. And the way you cast things is by putting the name of the class in parentheses, the name of the type in parentheses. And I bet we did that in Java 1, converting ints to floats and stuff like that. All right, now this reference is actually a reference to a sphere, so we can check to see if this sphere equals the one that was passed in. So if this dot radius not equal other dot radius, return false. And I did that for a specific way. I could have just otherwise returned true. Why did I word it like that? Because if this thing had multiple attributes, it'd be nice to just be able to copy and paste them. You know, do the names match? If not, return false. Do the ages match? If not, return false. Do the heights match? If not, return false. So this could have been written in any other number of ways. It could have said if this radius equals other radius, return true, else return false. I just know from experience that if I word like this, it makes it easier for me to add other attributes to compare, because very few objects you create are going to only have one variable. Alrighty, we ought to be going well now. It should say that the spheres are equal at this point. Hammer and broom it. The spheres are in fact equal. Now go and change one of those 10s to an 11, just to make sure that our code really does work. Alrighty. And it says that they're not equal. So by our criteria, which was that the radiuses are equal, this object, this class, now is able to compare itself. There's one more thing we ought to do though, because this code could crash pretty easily. And that's if we passed it the wrong kind of object when we compared it. Like maybe a string, I don't know. So I'm going to go back to my client code. I'm just doing this to deliberately make it crash. String name is equal to Joe, right? So I'm adding this above my dot equals, and then I'm going to say if s1 dot equals parentheses name. The syntax allows that, but it's going to give me a runtime error. And boom, what is that runtime error? It says string cannot be cast to a sphere. So this statement right here is blowing up, where we try to convert whatever was passed in into a sphere. So we need to kind of qualify it. We need to make sure that what object O is, that it really is a sphere. Otherwise, this is not going to work. So let's see if we can do that. There's another keyword called instance of. I think I'm about to botch this. So the instance of operator is used to test whether the object is an instance of the specific class. So if O instance of sphere, then we're good to go and we want to do all this stuff. But I think I'm going to say if not O instance of sphere, return false. Right. Because if it's not a sphere, we want to bail out immediately as soon as possible. And I've got my syntax wrong, bad operand type. Well, what would have happened if I'd done that? It doesn't think that's a bad operand type. Okay, fine. If O instance of sphere equals false, return false. That's lame. I shouldn't have to do it that way, but I'm not going to take the time to correct the syntax. I'd probably just have to put whatever I had in there inside parentheses. Okay, so now the code is not going to break. It's not going to crash just because I'm trying to compare it to an object that is not compatible with a sphere. And it says the spheres are not equal. We could make this a little bit more, you know. It's not a good idea to litter your classes with print messages, but we could conceivably make this dot equals thing print out a message saying, you know, object is not a sphere. If this is false, print not a sphere, then return false. But you really don't want to make your classes noisy. You don't want them spitting things out to the screen. So I'm not going to bother doing that. Does that kind of make sense what we've done here? We added a toString method so that we could print the stuff out easily. we've added a dot equals method so that we can compare two objects. In order to compare them, we have to use this specific method header, this exact syntax, because that's how the syntax of the root object class is declared. So we had to match it. And in order to match it, we had to use this as our parameter. And since we had that as our parameter, we had to convert that to a reference of a sphere by using casting. Once we had the sphere good, then we could start checking the members.
So in Java, every time you want to compare something, you have to do the Boolean, and then you have to do equals object, and then you have to change.
If you're gonna use this syntax, s1 dot equals.
But you can use different syntax.
Well, you could make a different name for it.
Right. And then,
You know, and then you wouldn't have to follow this exact sequence of getting an O and then turning it into a sphere. You know, I guess you could call it is the same as, or
yeah.
dot equal rather than dot equals. But if you're going to use that specific method name, which is the recommended, the canonical way of doing it in Java, since you're just supposed to burn it into your head that anytime you have objects, if you want to compare them, you ought to be able to call it s1 dot equals and have it work. Now, in the C++ language, you can do what's known as overriding operators, which means that you can override the equal operator, meaning that you could do if s1 equals s2. You still have to write it in a very specific syntax. You're just allowed to replace it, what equal does. And this language does not allow you to override operators to that extent. But you'd have to do the same kind of steps then. You'd have to convert it to the object that you were comparing it to, and then do that. There's one more slight performance enhancement we could make, which is if this equal O return true, because that just means that they're occupying the same memory address. So I'm going to go ahead and do that. If this equals O, then return true. Why do anything else if we know it's the same exact object? Well, when would that happen? Well, like if you did this. If S1 equals S1, right? If we do that, then this is, in fact, the same address as this, and so we want to go ahead and return true without doing any more of this rigmarole. And I really would like this dot equals method to check, but that's not necessary, right? The code will work just fine without it. It's just a slight performance enhancement. I do want to add one more member, though, just so that we're checking two things. Do I want to do it to this class? Yeah, I think I do. All right, so what else could a sphere have besides a radius? I don't know. A density. We're not going to implement density. We're just going to arbitrarily set it equal to 0. But if we were going to go back and modify it so that, you know, it did work, we would want equals to check that as well. The only reason I'm adding that is because I want to demonstrate making the dot equals method check more than one attribute. Not just radius, but density. Wouldn't take us long to add density to our, to our constructor there. We could do int comma density, or why did I make that an int? That should have been a double because radius supports doubles. I'm going to change that right now. It doesn't matter, but double radius, and then double density. And so this dot density is equal to the density parameter. And I should add getters and setters to density. I'm kind of taking a shortcut by not. But now the equals method also needs to check that variable. And by the way, when we did that, when we changed the constructor, it broke our code over here because our code over here, the client code is assuming is only passing in one argument, whereas now our constructor requires two. But anyways, so here, not only do we want to check to see if the radiuses are the same, we want to check to see if the densities are the same. If this dot density not equal other dot density. Return false. So you see what I mean by the way that I did that? I could just start tacking on comparisons for other attributes, for other variables. We just chain them up, you know. Makes them easy to do that way. Let's go back to our client code. If we are done typing this, I don't want to type too quickly. Are we good here? Okay. Fix that problem, I'm going to have to go over to where I create my objects, and I'm going to have to pass in a second argument. Let's say this one has a density of 1.0, and this one also has a density of 1.0. In fact, I want to see them both be the same, so I'm going to make the parameter, the argument list exactly the same for both of them. Sphere 1 is 10 with a density of 1, and sphere 2 is a density of 1. Now when I run it, it should say that they're the same. But I left that dumb little change there where I was comparing the object against itself. I'm going to fix that. So if S1 equals S2. And it says they're equal. But if I change one of the radiuses, excuse me, one of the densities, he's got a density of 2 rather than 1. And I run them. They're not equal. Okay, all is well in sphere land. So enhancements I want to make to my sphere class is I want to do a get volume method and a get mass method. And the way you calculate mass is that mass is equal to the volume times density. So really, in this case, mass is going to equal get volume times density, or this dot, you know, get volume times this dot density. That's going to be how we calculate mass. What's the volume of a sphere? The volume of a sphere is it just pi r cubed? I believe that to be the case. Four-thirds pi r cubed. Okay. Remember from beginning Java that if you divide an int by an int, it rounds it down. So we can't just say 4 divided by 3. We're going to have to do 4.0 divided by 3 or 3.0. So get volumes formula should be 4.0 divided by 3.0 times pi, math.pi, times radius cubed. So math.radius, excuse me, math.pow, P-O-W, power of this dot radius to the power of 3. So that's the formula for the volume. Volume is equal to that. And this is the formula for mass. So part of your homework assignment, add these two methods to the sphere class, and then expand the client class to ask for the radius and the density of each sphere, and compare to see if they are equal. Also, print their volume and mass. And although we didn't illustrate it, we should probably modify it should show the density as well as the radius in our toString. So that'll be the last bullet point. I'll prettify that, but that's our homework assignment based on the sphere. Now that didn't touch upon class methods, class members. So we're going to write a really dummy short little class called robot. So I'm going to add that. I'm going to go and add a new class to my package. So new Java class, robot, finish. And all I know about my robot is the number of legs it has, int legs, and whether they are all disabled or not. Static, Boolean, disable all, are all disabled. For some reason, if you shut one robot down, all the robots shut down. Now let's make a dummy method called move. Public void move. If he's disabled, then let's print out system.out.println. Can't move, all robots disabled. Else system.out.println. Okay, boss, I'm moving. Don't even know why I have legs here. Spurious to this example. Why don't we make one called speed instead? Double speed. So I'm changing this print line to say, okay, boss, I'm moving, speed equals, and then after the quote, plus speed, or plus this dot speed. And I'm going to build it to make sure I don't have any egregious syntax errors and not give everybody time to catch up typing. So since this is static, it means it's a class variable. It applies to the class as a whole. It applies to every object. All the objects are abiding by the behavior of this one switch. We can't disable one without disabling all of them. Kind of dumb, but it's the only example that came up to me that fast. And this is an instance variable because each robot can have its own speed. And let's make one more static variable. static int count, which is going to be how many robots have been created. So each time we create a new robot, we will add one to the count. So I'm going to add a constructor so that we can set the speed, but it's also going to increment this class variable counter. So constructor has the same name as the class, public robot, and it's going to take double speed as its parameter. And so we set this dot speed equal to speed. And we're also going to add one to counter, this dot count plus plus. And that's our class. I don't think we need to gussy it up with anything else. Sure, we could add a toString method and a print, an equals method and all that. If we were going to add equals, all we would need to compare would be the instance variable. You don't need to compare the class variables because they're the same for every object made from this class. So we already know that that's true. We already know that So let's, are we good? This compile for everybody? Okay, because I'm going to flip back to my client code, if I can spot it. Why don't I just close this guy? All right, up here at the top, I'm going to make a few robots. Robot Bob equals new robot. Bob can move 10 miles an hour. If I'd been thinking in advance, I would have called them droids, so I could call them R2 and C3PO. Now, robot Sue is equal to new robot, and she can move 20 miles an hour. Let's make one more robot. Robot Joe is equal to new robot who can move 30 miles per hour. All right, let's find out how many robots we have made. System.out.println robots made so far equals end quote plus robot.count. Now let's make them move. Bob.move. Sue.move. Joe.move. Now let's disable all of them. I forgot to initialize the disabled value. But that's okay because all Boolean variables initialize to false if they are declared as part of a class. But I like seeing that actually. So I'm going back to my robot class. And also, I really don't like, forgive me for changing this midstream, but I hate using negative words as my Booleans. I'd rather say enabled rather than disabled. So now that I'm thinking about it, I'm going to change that line, static Boolean, to be static Boolean enabled equals sugar. So, our robot swarm is enabled, but now I'm going to disable them. Robot.enabled equals false. Now I'm going to try to move them again. I'm just going to copy those 3 lines, paste them. And now all the robots, they will no longer be able to move. We will get error messages when we try to move them. Or we'll get syntax errors.
I think in a robot.
Can I
In a
find
robot class.
there we go. Yep. I changed the name of the variable from enabled to disabled. That was a mistake because I forgot to fix it down here. So back in the robot class where it says if disabled, make it if not enabled. I'm getting a little warning here saying accessing static field count. If you're using a static field, you're not supposed to prefix it with the this reference because that kind of indicates that it's an instance member. So I'm going to correct that just to make the warning go away. So inside the constructor, I'm removing this dot. It doesn't stop it from working. The compiler's smart enough to make it work anyways. But it's not good form because count does not vary on an instance by instance basis, right? We print out the total count of robots. If we printed out Bob.count, it would still be 3. And Sue.count, that would be 3. And Joe.count, that would be 3 because we created 3 robots. But it doesn't make sense to think of the count of robots as being attached to any one particular one, right? Instead, it applies to our class as a whole. And the same for whether they are enabled, which was a silly move on our designer's part to make all the robots stop moving just because we disable one, but okay. So now when I run it, our 3 robots moved, but then we flip that switch and it says can't move, all robots disabled. Hope that kind of makes sense. Hope that kind of lodges in the brain about the difference between a class member and an instance member. So in terms of UML, what UML stands for, Unified Modeling Language, you can make a diagram of the way a class works, and a UML consists of 3 blocks. The top block is the name of the class. The middle block are the variables, and then the bottom block are the members. So if we were going to make a UML for our sphere class, it would look something like this. So our top box. What's the name of the class? It's called sphere. What data elements, what variables did we have in our sphere class? We had 2. We had a radius and we had a density, and they were both floats. And they were both private. So you indicate that they're private with a minus sign in front of them. So radius is a float, density is a float. Then we had some methods. We had getters and setters for them. So the methods are listed in the bottom block of the UML. So we had get. These are public methods, which you indicate with plus signs. Now I wish that I'd drawn these lines some other way than with rows of dashes, but hopefully that makes sense. So we had get radius, and what did get radius returned? Was it void or was it a float? It returns something. It returns a float. And actually these are doubles, not floats. My mistake. Set radius did not return anything, so we would define it as void, but it accepted an argument. It accepted a double as an argument. We had an equals method, which returned a Boolean. And what did it take as its argument? It took an object. We had a toString method, which returned a string. I don't recall any others. Doesn't mean there aren't them. get radius, set radius, toString, and equals. Okay, that was it. So that's the UML for this particular class. When we're done, we will have added get volume and get mass to it. So our second bit of homework. Write a class named cube. And yeah, we probably did this in Java 1. Don't just go grab that class. 3 members, 3 instance variables. As a matter of fact, why don't we do it in the form of a UML? So cube is going to have a height, a width, and a depth. They're all going to be private. Also, our cube class is going to have, I'm not going to take the time to write them out, but it should have getters and setters for each. They should be public. Add a constructor, which takes height, width. And it's weird about UML having the order reversed, because about every language you use, the type comes first. And then depth. Then it's going to have get area, which returns a double. And it's going to have get volume. And get area should be surface area. Get surface area, which returns a double. Please also add a toString method. And an equals method. So write a class named cube that meets the following UML requirements. Then write client code that creates 2 cubes, compares them, and prints out their volume and surface area. All right, that makes sense? We'll be good to go with that? All right. Well, let's go ahead and make a Dropbox for what we did today. And then you can download it, again, when you want to create your Sphere class. I will also upload that as notes, of course, the Sphere class. I'm going to go ahead and post the quiz material for Chapter 6 pretty soon, and we'll just make it due like in 2 weeks. So do go ahead and finish reading up Chapter 6.
the sphere and cube in the in-class section.
Alrighty, I'll fix
I
that.
think you just changed it. That's what I saw, and then I refreshed it.
Okay, it's good now.
Went to the right place? Okay, good, good. All right.